Today we are diving into the world of surds, an essential topic for your IGCSE Extended Mathematics exam. By the end of this lesson, you will be able to simplify surds, perform basic operations like addition and multiplication, and rationalize denominators to ensure your answers are in the simplest form possible. A surd is simply an irrational number that is left in root form because its exact value cannot be written as a whole number or a fraction, for example, the square root of 2. For your exam, keeping numbers as surds allows for exact calculations without rounding errors. Let's begin with our first goal, simplifying surds. To simplify a surd, we look for the largest square number that is a factor of the number under the root. Recall your square numbers: 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. We use the rule that the square root of a times b is equal to the square root of a multiplied by the square root of b. Let's simplify the square root of 48. We need the largest square factor of 48. 16 is a square number, and it goes into 48 3 times. So, we can rewrite this as the square root of 16 times 3. Using our rule, this becomes the square root of 16 multiplied by the square root of 3. Since the square root of 16 is exactly 4, our simplified answer is 4 root 3. If you had chosen 4 as a factor, you would get 2 root 12. But notice that 12 still has a square factor of 4, so you would have to simplify again. Always aim for the largest square factor to save time. Next, let's learn how to add and subtract surds. Our objective is to add and subtract like surds. The golden rule here is that you can only add or subtract like surds. Think of this just like basic algebra, where you can add 2x and 3x to get 5x, but you cannot add x and y. Consider this example, 5 root 2 plus 3 root 2. In this expression, both terms involve the square root of 2. They are like surds. We simply add the coefficients. 5 plus 3 is 8, so the result is 8 root 2. Wait, what about the square root of 75 minus the square root of 12? At first glance, these look like unlike surds because 75 and 12 are different. However, in IGCSE questions, you must always simplify first to see if hidden like surds exist. The square root of 75 simplifies to 5 root 3, since 25 is a square factor. The square root of 12 simplifies to 2 root 3, since 4 is a square factor. Now we have 5 root 3, 2 root 3. Since they both contain root 3, we can subtract them to get 3 root 3. Always look to simplify before deciding if terms can be combined. Now we move on to multiplication and division. These operations are often more straightforward because you don't need like surds to perform them. We use two fundamental properties: the square root of a times the square root of b equals the square root of ab, and the square root of a divided by the square root of b equals the square root of the fraction a over b. Let's try a multiplication. When we have coefficients, we multiply the numbers outside the roots together and the numbers inside the roots together. 3 times 5 is 15. Inside the root, 2 times 6 is 12. This gives us 15 root 12. But remember, we must always check if we can simplify. Since root 12 is 2 root 3, we multiply 15 by 2. Our final simplified answer is 30 root 3. Now for division. Using our rule, we can put both numbers under a single square root. 80 divided by 5 is 16. The square root of 16 is exactly 4. So root 80 divided by root 5 simplifies perfectly to the integer 4. Our final and perhaps most important topic for the extended exam is rationalizing the denominator. In mathematics, it is considered untidy to leave a surd in the denominator of a fraction. Rationalizing is the process of removing the surd from the bottom while keeping the value of the fraction the same. Let's look at case 1, a single surd denominator. For example, 6 over root 3. To get rid of a single square root, we multiply the top and the bottom of the fraction by that same square root. This is the same as multiplying by 1, so the value doesn't change. On the top, we get 6 root 3. On the bottom, root 3 times root 3 is simply 3. Now we simplify the fraction. 6 divided by 3 is 2. So, 6 over root 3 simplifies to 2 root 3. Case 2 involves a binomial denominator, for example, 2 over the bracket 3 minus root 5. If the denominator is a sum or difference, like 3 minus root 5, we multiply by the conjugate. The conjugate is the same expression but with the opposite sign in the middle. On the top, we have 2 times the bracket 3 plus root 5, which is 6 plus 2 root 5. The bottom is a difference of 2 squares. We get 3 squared minus the square root of 5 squared. The bottom becomes 9 5, which is 4. Putting it together, we have 6 plus 2 root 5 over 4. We can simplify this by dividing every term by 2. Our rationalized answer is 3 plus root 5 all over 2. Mastering this conjugate method is key for higher-level marks. To wrap up, let's look at a typical IGCSE extended past paper style question that combines these skills. Show that the square root of 50 plus the square root of 18, all divided by the square root of 8, simplifies to an integer. This question asks us to simplify a complex fraction. It might look intimidating, but we just apply our steps one by one. First, we simplify the surds on top. Root 50 becomes 5 root 2, and root 18 becomes 3 root 2. Since they are both root 2 terms, we add them together to get 8 root 2. Now for the bottom. Root 8 is the same as root 4 times root 2, which simplifies to 2 root 2. Now we have 8 root 2 divided by 2 root 2. The root 2 on the top and bottom cancel each other out. Finally, 8 divided by 2 is 4. We have met all our objectives. We simplified, added and divided surds to reach an integer result. You are now ready to tackle surds in your IGCSE extended exam. Remember to always look for those square factors first.